Welcome to our first video from Chapter 10. We're going to be looking at area, and we're just going to focus on three formulas today. The first one's for a rectangle, and I think we kind of know the general shape of a rectangle. It's got to have right angles in the corner. We're going to get into those definitions really well in our second semester. But right now, I think we understand that the area formula is base times height. Let's just think about why that is. So right now in this picture, the base from D to G is 8. And the height, even though you don't see point H up there, it's kind of hidden right now, but it's saying that basically this part right here is 4. We understand that 8 times 4 should get us something around 32. But what does this mean for area? Well, it means, if I zoom in here a little bit, I'm basically, let's see if I can actually do this somewhat good. I'm going to split up this rectangle basically into 8 parts this way. And then I'd be splitting it into 4 parts this way. And I know the picture is not super exact, but if you were to count up all the squares there are 32 of them. So we're saying if we have these dimensions, how many squares, each a centimeter on the side, can we fit into this picture? And that's where we get the fundamental idea of base times height. So if we go back to our notes, get my mouse here a second, there we go. So back to our notes, we're pretty familiar with this one. A parallelogram, opposite sides are parallel, has the same basic formula. Still base times height. So again, I just want to go back to this and show you, if I were to kind of change this into a parallelogram now, and I maybe show you this part here. Now this is the height. Notice that the height is the same in the rectangle. None of these measurements are changing as I go from a rectangle to a parallelogram. The basic measurements of DG, the base, are the same. The height still stays 4, and our area is also exactly the same. So that's just a little bit of a visual aid for why we can still use the same formula there. Okay, and then finally, if I scroll up here just a little bit, a triangle, again, I think we have a good understanding that triangle is 1/2 times base times height. Let's just look at why that is true. So go back to Sketchpad here, go to my second window right there. Okay, so now I have a rectangle again, and right now I have it set for an area to be 80 right up here. If I were to show you the triangle that we have right there, a triangle basically takes up half of it. And if I were to just measure the area of maybe that green triangle, okay, I get exactly half of the yellow rectangle. And so it makes sense to take the same formula as the rectangle and just take half of it. And I could certainly, again, modify this, and for a parallelogram, we basically would also take a parallelogram, split it into 2 equal parts, and that formula still seems to work for a triangle. So just want to show you a little bit where those formulas actually came from. So let's just go through a few examples here. We're going to focus a little bit more on parallelograms in our notes. I'm hopeful that you have an understanding, I guess, of triangles and rectangles already, but we certainly will be practicing some of that in our homework. For example 1, it says, what is the area of this parallelogram? They give you 3 measurements, and what you need to take away from this is that some of them are extra. Okay, this right here is the base. This is the height, and I know that's the height because it's at a right angle to the base. So this 4.5 right here is actually just extra. We don't need to know that. And as I go through and I solve the problem, the area of this is just base times height, so 5 times 4, that would get us 20. And so in general, that's the answer that we want, but if they're giving us dimensions, we also want to say that we have that many inches squared in this case. Again, going back to what I showed you in the rectangle earlier, when I could fit 32 boxes in that shape, those are 32 square units. Same thing here, I could fit in 20 square inch boxes in here. I'd have to cut some up and kind of fit them in specially, but 20 of them should fit in there. Okay, our second example, again, you see 3 numbers there. We're still looking at a parallelogram. This one's a little bit different now because we see some measurements that are on the outside. Those dotted lines mean we're kind of working on the outside now. When I look at this one, I need to look for that right angle. This is our base, and then this is going to be our height right there because that is at a right angle to the base. And I have a feeling you've seen some pictures like this with triangles before, where the height ended up being outside. So you got to kind of think back to that. Again, this 4.6 is extra. So when we're dealing with this kind of stuff, we always want to see a right angle somehow connecting the base and the height idea. So again, as we go through and we find area, it's just base times height. My base was 2. My height in this problem is 3.5. 2 times 3.5 is 7, and that's going to be in square centimeters. Okay, let me erase this. There we go. We'll scroll down here. Our last question in this video. A little bit more complicated. Now we have, this is our symbol for parallelogram. We have parallelogram A, B, C, D, so we know the formula base times height will work. We want to know what DE is to the nearest tenth. And DE is going right here. So if you notice, this is my base, or this could be my base, and then DE would be the height that goes with it, because we have that right angle right here. So if I knew the area, I would know area, I would know base, and I could work backwards to find height, because I would know 2 of the 3 things in our formula. But I don't know the area, so I'm going to try to find it. So what I want you to do, even though you can't do this on your paper, envision just kind of twisting this shape a second, like so. And if we look at it from a different perspective, now we have a base of 13. And remember, height has to be at a right angle. This is the height that would go with it. This height is 9. And I can find the area of the parallelogram that way, even though this question is not asking for it. I need to know the area so that when I rotate this back, I can then use that known area to help me find the piece I'm actually looking for. So that's pretty complicated. So we're going to find the area first. In this case, it'd be area is the base, which is 13, and the height was 9 when it's rotated this way. So you have to figure out what 13 times 9 is. 13 times 9 is 117. Okay, and then I'm just going to kind of split that off because that's the end of that part of the problem. I'm going to rotate this back like so, and now I want you to think of it as my base is 9.4, and this is my height, which I'm trying to find, and I already know the area. So I'll pick a different color here, go back to red. So now, if area equals base times height, I know the area of this shape has to be 117. In this perspective, the base is 9.4, and I'm trying to solve for the height. So we would want to go, we would divide by 9.4 on both sides, so the height will equal 117 divided by 9.4. Okay, so 117 divided by 9.4, and we get 12 point, let's see, they say round to the nearest tenth, so 12.4. So H in this case would equal 12.4. So that's a little bit more of a complicated example. You have to think a little bit about what you know, what you would need to know. Are there any other different ways of finding some of this info? Just a really good problem. You should be very used to this in the end, I guess. And then one thing I just noted, I guess they're really asking us to find DE. So just note that the height in this case is DE. We have figured out what that part was. Okay, I'm going to stop there. Jot down some questions if you have any, and we'll see you in class.